Introduction to density. Density is equal to mass divided by volume. These have very specific units, grams per milliliter, which is g per ml, or grams per centimeter cubed. Mass then needs to always be in grams, and your volume needs to be in milliliters. You should also be able to calculate using this equation for mass. Mass is equal to density times volume. Volume is equal to mass divided by density. Good problem-solving techniques require that you always write the equation, list the variables underneath your equation with the units, and based on the type of equation you're using, make sure you change it to the proper units for that equation, and always read and check to make sure that you truly answered the question. Here's a typical density problem. It says, what is the density? When I solve problems, I immediately stop reading the rest of the problem because it's asking me to calculate density. So what I will do then is immediately write the equation down based on what it's asking me to calculate. Then I'm going to list the variables that appear in my equation. I need a mass and a volume. When I go back up into the problem, I can see that this is going to be the mass. It has the metric unit gram in it. Remember, gram measures mass. So m is equal to 256.8 decigrams. I know that density needs to be in grams, so the proper units is to switch it to grams, which is 25.68. The volume then is 69.2 centiliters, but it needs to be in milliliters for density. And here is that conversion. Once I've written my equation, listed my variables with the units, converted to the proper units required for density, I then will plug and chug, is what I say, and I put my mass divided by volume. This is my answer with the proper units. This says, what is the volume? Again, I stop reading as soon as it asks, or I can determine what it's asking me to find, and it's volume. So immediately I will write the equation for volume. Volume is equal to mass divided by density. This means I need to find mass and density. My mass is 1.78 kilograms. That is not a proper unit for density, and we will convert that in just a moment. Density is equal to this value. Remember, this is your metric moving dot, and a lot of students will write that on their exam when they take it. And I'm going to put my 1.78 kilograms under the kilo column, and as you can see, I need to move to the right, and I need to move 3 columns over to get to grams, which is the mass required for density. So I moved it over twice, and here's the third time I moved my dot. I'm going to fill in the troughs with 0. So 1.78 kilograms is going to be equal to 1,780 grams. Put your values in where it belongs in the equation, and here's my answer. The very last step was to go back and make sure that you truly answered what was required of the problem. It says, what's the volume in centiliters? I have it in centimeters cubed. Remember the metric link that 1 centimeter cubed is equal to 1 milliliter. It's a 1-to-1 ratio. And so therefore, if I have 372 centimeter cubed, it equals exactly the same amount of milliliters. Now that I have it in milliliters, I can use the metric moving dot to convert it to centiliters. Density by displacement. You will use this in the lab when you're doing pennies and your zinc shot. You want to be able to get the volume of an irregular shaped object. And what you're going to do is to get your graduated cylinder, fill it up with water, and make sure you read the initial level of that water. Place the object in that graduated cylinder, and the amount of water that is displaced by the solid object will be its volume. So take the final volume after you've placed the object in the graduated cylinder of water and minus the initial volume. So there are 2 volume readings to get the volume of a solid. Let's take a look at a typical problem that might occur in the lab. It says determine the density of 20 pre-1983 pennies. This is also going to ask for what is the percent error. Again, it says determine the density. There's my equation. I would weigh 20 pennies on a scale and say the mass is 54.8 grams. It's in the proper unit, so I don't have to switch the units. I get a graduated cylinder out. I'm going to fill it up with water so that when I place my pennies in there, it would be a larger volume than my pennies. Take that initial reading, which is 35.6 milliliters, and then after I place my pennies in it, the water will be raised to a new level of 44.9. When I minus these final from the initial volume, I will get the volume of those pennies. After I get my mass and volume, I put it into my equation, and I get 5.89 grams per milliliter. Everything has a unit. Let's look at percent error. Percent error is just asking you how far was your value that you calculated in the experiment, how far was it from the literature value or the actual value that you would find in a chemistry handbook. The value for copper pennies is 6.93 grams per milliliter. Your formula for percent error is to take the value that you actually determined minus the lit value that comes from the book divided by the lit value. Again, lit values will be given to you or it'll be found on a table. These are absolute values. Absolute value means it doesn't matter if there's a negative number in these two lines. It is just going to be literally the number times 100. 100 will allow you to get a percentage. So let's take a look at what ours would look like. This is the actual value we got on the previous problem minus the lit value divided by the lit value. Again, it's going to be the absolute value in there times 100. Students who may not be very calculator savvy, what we'll do is they will take the numerator up here and get a value of it, which would be a negative 1.04 divided by the denominator. Again, it's the absolute value. So notice that this negative is going to turn into a positive because you're just interested in the value. And when you do that, you get a value of 15.01%. This is saying that your actual number, 5.89, was 15% off away from the literature value. So you had a 15% error. And actually, it's not wrong if you had a negative 15.01. The negative 15.01 is actually telling you that you were below the literature value.